record, and then I will upload on YouTube. Okay, so chapter 5, Poverty, Inequality, and Development. You can find this in Todaro's book, chapter 5. As usual, this is just the summary of the chapter. Okay, so regarding the distribution and development, we will have 7 critical questions to be answered here. So these questions are raised because we are concerned with the issue regarding inequality. So it has been said that there is a trade-off between growth and inequality. So that's why now we have these 7 critical questions. So the first one is, what is the extent of relative inequality and how is this related to the extent of poverty? So like I said before, because inequality is said to be a trade-off of the growth. So how far we are going to tolerate inequality for the sake of economic growth, and how is this related to the extent of poverty? So that's an important issue. And then who are the poor? So who are the poor? And then who benefits from economic growth? Yep. So if inequality and growth is a trade-off, so who actually benefits from economic growth? And then does rapid growth necessarily cause greater income inequality? Does rapid growth necessarily cause greater income inequality? And then do the poor benefit from growth? Okay. And then are high levels of inequality always bad? So is inequality always bad? Is it possible to have a society where we have zero inequality? Now, we will answer that today. And then what policies can reduce poverty? Okay. So those are the 7 critical questions regarding distribution and development. Okay, the first thing that we will learn today is how to measure inequality and poverty. So there are some ways to measure inequality and poverty. We can use size distributions or using quantiles and deciles. And also we have Lorenz curves and we have Gini coefficients. You must be very familiar with Gini coefficients, right? Because we have talked about this, I think, in the first week. And then we also talk about this in the second or third week, I don't remember. And then we also have functional distributions. So we will talk about many ways to measure inequality and poverty. So this is example of the size distributions. This is the typical size distribution of personal income in developing country by income shares. So basically what you want to do is you want to order the individual based on their personal income. So based on their personal income, this is from the smallest to the largest. For example, in this example, we have 20 people here, 20 individuals, and then we order them from the whose income is the lowest to whose income is the biggest. And that's what we want. And then what we want to do is we're going to break this income into quantiles and into deciles. Okay, this is based on the share of total income. So if they are here, they are in the 5 quantiles. If they are here, they are at the 9th quantiles, and then 13 quantiles here, 22 quantiles here, and then 51 quantiles here. So basically, when you do quantiles, you break down the whole population into 5 proportional part. So 5 proportional part here. And then with the deciles, this is you divide it by 10 parts. So you already know how to calculate decile in your statistic class. So basically, this is one way to measure inequality and poverty. So if someone lives in the quantile 5, then you can assume that they have a very low personal income compared to someone who lives in the 51st quintile. If someone in the 1.8 deciles here, then they must have much less personal income compared to someone who live in this decile. So that's how you one of the way to measure inequality. Okay, this is the typical size distribution. Okay, and then the second one, this is very popular, the Lorenz curve. So the Lorenz curve looks like this. So this here, like half moon here, this is the Lorenz curve. The Lorenz curve measure the inequality, and then the 45-degree angle here, this is, wait a minute, the 45-degree angle here, this is the line of equality. So the farther the Lorenz curve from the line of equality, it means the society is more unequal. The inequality is quite high, okay? And then how do you read Lorenz curve? So this is how you read Lorenz curve. The y-axis here, this is the percentage of income, and the x-axis here is the percentage of income recipient. So basically, if for example, this 20%, so this is 20% of the society, sorry, 20% of the poorest 20% of the society is in here, and they only receive in here about this is about less than 10%, maybe this is only 7%. So the poorest 20% of the society, they receive 7% of the total income. Meanwhile, the richest 20% is in here. Hey, this is the same color. You will get confused because of it. And then here, I forgot to. Okay, let's consider that. For example, and then the richest 20%, they receive about, let's say, 48% of the income. So this is what makes it unequal, right? The poorest 20% receive 7% of the total income, meanwhile the richest 20% receive about almost half of the total income. So this is what makes it unequal. And this is why when the Lorenz curve get very close to the line of equality, it means the inequality is low, right? So we will see here that the closer the Lorenz curve with the line of inequality means that the society is more equal, okay? Relatively equal distribution. Meanwhile, the farther the Lorenz curve from the line of equality, then the society is relatively unequal. Because this is how you read Lorenz curve. The poorest 20% only receive about 7% of the total income. Meanwhile, the richest 20% receive about 48% of the total income. Okay. And we use Lorenz, why we need Lorenz curve? Because we are going to calculate the Gini coefficient using Lorenz curve. Okay, let me undo this. Okay. So, like I said before, this is, so this is the relatively equal distribution. Meanwhile, this is the relatively unequal distribution. So the closer the Lorenz curve to the line of equality, it means that the society is relatively equal. And the farther, then the society is relatively unequal. Okay. And then we are going to estimate Gini coefficient. This is one of the most popular measurement for inequality. So in order to calculate Gini coefficient, you need Lorenz curve, because Gini coefficient, you calculate it, how to calculate Gini coefficient is from the Lorenz curve. You are going to calculate the shaded area E divided by total area BCD. So A divided by BCD, okay? That's the Gini coefficient. Gini coefficient range from 0 to 1. And the closer it is to 1, the more unequal. So closer to 1, more unequal. Okay, I think Indonesia is currently in 0.4 something, if I'm not mistaken, because I haven't checked again. Okay, and then there are a lot of possibility on the shape of Lorenz curve. So this is an example. Lorenz curve could shape like this. This is the line A, but it can also shape like this line B here. It can also shape like line C. It can also shape like line D here. So there are a lot of possibility. Depends on the society. Okay. So this is an illustration of functional income distribution in the market economy. So theoretically, in the market economy, the demand for labor is going to be equal marginal product per labor. And then this is the supply of labor. And in the equilibrium point here, this is where the wage rate is going to be. This is the market economy ideal theory. So this is if the market economy works very well and there is no market failure. So this is what's going to happen. The demand for labor is going to equal marginal product per labor. And then the equilibrium between supply and demand is going to be the wage rate. And then the number of people employed is going to be here. But it doesn't always happen in real life, right? Last week we have discussed that wage not always in the equilibrium point, because a lot of things, like for example, because they substitute human labor with machine, for example. So that's why the wage rate for human labor is very low, or maybe because the people who seek a job, they are unskilled, or maybe they cannot easily move from one sector to another, and other issue that we have discussed last week. Okay, if this works, if this ideal illustration works, then the inequality will not going to be so bad, right? Because the market is at their equilibrium point. But market fails and so does government. So that's why this ideal illustration doesn't happen in real life, okay? Okay, and then the next one, and we have talked about the size distribution, the Lorenz curve, and then the Gini coefficient. Now let's talk about some index. So there are some index that we can use to measure poverty. The first index is the Headcount Index. Basically, with the Headcount Index, you just calculate H divided by N, where H is the number of person who are poor. So the number of person who are poor, and then N is the total number of people. So the number of people who are poor divided by the total of the population. Okay, that's the headcount index. So headcount index is the how many people poor relatively in society, relatively to compare to those in the society. So that's the headcount index. Number of person who are poor divided by total number of people in the economy. Okay. And then the next one, we have poverty gap. The poverty gap, you calculate it by sigma H, or the number of people who are poor, times YP, subtract by YI, where YP here is the absolute poverty line. So this is the poverty line. What does it mean? What does poverty line mean? So poverty line stated, for example, like if your income, your monthly income is under $100, for example, then you are poor. So the $100 is the poverty line. So poverty line decides who is poor and who is not poor. So YP is the poverty line, and then YI is the income of the poor person. Okay, so basically this is the number of poor person, and then this is the poverty line subtract by the poor people's income. So that's the poverty gap. Okay, and then this is measuring the total poverty gap. So this is an illustration of a relatively large poverty gap, and this is an example of a relatively small poverty gap. You can already see why this is larger, because the area here is bigger than the area here. Okay, so this is a relatively large poverty gap. Okay. And then we can measure measuring absolute poverty. We can measure the average poverty gap, or APG. To measure APG, you just put the value of TPG, or total poverty gap, divided by total number of people in the economy. Okay. And then you will have a normalized poverty gap by put average poverty gap divided by the poverty line. This is the normalized poverty gap, or NPG. Okay. And then we also have the average income shortfall, or AIS here. Wait a minute. So the average income shortfall, or AIS, is the total poverty gap divided by the headcount of the poor. And then the AIS, it tells us by which amount the income of a poor person falls below the poverty line. So the distance between a poor person's income and the poverty line is the average income shortfall. Like, for example, if the poverty line is $100 and my income is $50, then my average income shortfall is $50. Okay. But the average income shortfall is calculated by TPG, or total poverty gap, divided by H, or the headcount. H is the number of poor person. Yeah, that's the number of poor person. So that's the average income shortfall. And then you will have a normalized income shortfall, or NIS here, equals with AIS, or average income shortfall, divided by YP or the poverty line. Okay. And then there is this Fgt index. You will find this a lot in the literature about development economics. So the Foster-Greer-Torbeck index. Actually, there are three types of Fgt index, if I'm not mistaken. Let me open your textbook. We have 0, 1, and 2. Yep. So there is Fgt 0, Fgt 0, and Fgt 1, and then Fgt 2. Okay. So first of all, you calculate Fgt using this formula here. Because this is an index, the notation of the Fgt index is P alpha. You can change the alpha, depends on whether you want to calculate Fgt 0, Fgt 1, or Fgt 2. So alpha, you can change it. You calculate it by 1 divided by n times sigma h times poverty line, subtract by personal income divided by poverty line to the power of alpha. Alpha depends on which FGT you're going to calculate. N is the number of person, H is the number of poor person, and then alpha is a parameter. So alpha is more than equal 0 or more than 0 here. When alpha equals to 0, we get the headcount index. So if you, when alpha equals 0, then we have the headcount index measure. So basically Fgt 0 is the headcount. This is the headcount measure, or this is the H divided by N, right? And then the Fgt 1, and then we have Fgt 2. And then when you when you put alpha equals to 1, then you calculate Fgt 1, which basically equals to poverty gap index. Poverty gap index. So usually we only use these two measurements. Either you do the headcount index or the Fgt 0 or the poverty gap index or the Fgt 1. But if you want to measure with the so if you want to have bigger weight for the poor population, like for example, with the poverty gap index and the headcount index, you actually have a cutoff, like below the cutoff, then someone is defined as poor. But if you want to have lower cutoff than that, then you use the FGT2. So the FGT2, the most common FGT specific index in development economics is FGT2 version, which is the lowest parameter to weigh income inequality along with poverty. So if you want to examine deeper the inequality in the poor community, then you use FGT2. So I will write it down here. With FGT2, you can measure inequality deeper among the poor population. Okay, among the poor population. So with the FGT1 and FGT0, you will examine the inequality. But with FGT2, you can examine inequality among the poor population. So between the poor, how is the inequality situation. Now that's where you use Fgt 2. Fgt 0 equals headcount index, Fgt 1 equals poverty gap index. Okay, so that's Fgt index. Okay, any question in this case? Not yet. Okay, I will continue. And then the next measurement is the newly introduced multidimensional poverty index. So now we have a multi-dimensional poverty index, or MPI. Okay, the identification of poverty status through dual cutoff. As you notice, the previous measurement, we only use income as the parameter to define whether someone is poor or not. Now with the MPI, we will examine other dimension as well. So this MPI, it identifies poverty status using dual cutoff, the first cutoff level within each dimension, and the second cutoff in the number of dimension in which a person must be deprived to be deemed multidimensionally poor. So the first is basically cut off in the dimension, like for example, falling below a poverty line if they spend less than $1.25 a day. So this is the dimension of income poverty. And then the second one, cut off in the number of dimension in which a person must be deprived to be deemed multidimensionally poor. So MPI focus on the deprivation in health, education, and standard of living. And each receive equal total weight. So the difference between MPI and the other measurement is in this MPI, we have other than income dimension. So if the first one is the income dimension, then the other, the second cutoff here, this is other than income dimension. For example, you define someone is poor when they do not finish elementary education. So you define someone is poor when they spend less than $1.25 a day and they do not finish elementary school. And the weight for the income and the education dimension is equal. So if you only have two elements here, then each element will weight half. If you have three elements, like for example, a health element, then each of the element will receive 1/3. So that's basically what multi-dimensional poverty index. Okay. So these are the MPI indicators. So we have health. Okay. Whether any child, oh sorry. So you can define this health indicator, like for example, with whether any child has died in the family and whether any adult or child malnourished, and then weighted equally. Okay. And then with the, oh sorry, let me rephrase that because it wasn't. Okay, for example, for the health indicators, two indicators with equal weight. The first one is whether any child has died in the family, and then whether any adult or child in the family is malnourished, it will be weighted equally. So those two indicators of health, whether a child has died and then whether anyone is malnourished, they will be weighted equally. Each count as 1/6 toward the maximum deprivation in the MPI. And then for the education, for example, the two indicators will have equal weight. First one is whether no household member complete 5 years of schooling, and whether any school-age child is out of school for grades 1 through 8. So both will count as 1/6 towards the MPI. And then the standard living, equal weight on 6 deprivation. So the standard of living indicators are lack of electricity, insufficient safe drinking water, inadequate sanitation, inadequate flooring, unimproved cooking fuel, lack of more than 5 assets, telephone, radio, TV, bicycle, and motorbike. And all will have equal weight. 18. That's the example. Okay. And then after that, we will have the interaction of the deprivation. So building the index from household measures up to the aggregate measure. Rather than using already aggregated statistic, MPI approach takes account on multiplied or interactive harm done when multiple deprivation are experienced by the same individual or family. So with the MPI, they will build the index from a household, and then they will aggregate the index. This is different from our common poverty index because it use already aggregated statistic. So MPI built their index from the micro perspective to the macro perspective, and they count for multi-dimensional, not only income. And then MPI approach takes account of multiplied or interactive harm done when multiple deprivation are experienced by the same individual or family. So someone can deprive in health, someone at the same time, that person can also deprive in education, for example. MPI can take account on that matter. And then the MPI approach assumes an individual's lack of capability in one area can only to a degree to be made up by other capabilities. Capabilities are treated as substitutes up to a point, but then as complement. So I think we have talked about this before. So with the MPI, when someone is lack in one ability, like for example, lack in health or lack in education, then it cannot always be substitute with other. Like for example, when someone is lack in health, and then you give them money, it cannot solve 100% the health problem because the MPI treated the capabilities as substitutes up to a point, but then as a complement. So that's why it is also possible for someone to deprive in more than one aspect. Someone can deprive both in health and education, and also in income and standard of living at the same time. I think we talk about this when we discuss about the new HDI index, where the old HDI still consider each of the element substitutes, but the truth is they are not entirely substitute. Someone can deprive in more than one dimension at the same time. Okay. And then computing MPI. The MPI for the country or region or group is then computed. So after you have all of the data from household, and then you will aggregate measure, and then you can compute the MPI for the country or the region or the group. A convenient way to express the result value is H times A. The product of the headcount ratio, H, and the average intensity of deprivation. So you calculate the headcount ratio times the um, average intensity of deprivation. The the average intensity of deprivation is the percent of weighted indicators for which poor households are deprived on average. The adjusted headcount ratio, HA, is readily calculated. So the result of using this MPI is HA, or the adjusted headcount ratio. HA satisfies some desirable properties, for example, dimensional monotonicity. It is said that if a person already identified as poor becomes deprived in another indicator, she is measured as even poorer. Not the case using simple headcount ratio. So this is the characteristic of the adjusted headcount ratio. With the headcount ratio, you just calculated how much part of the society are poor, but the adjusted headcount ratio, you can analyze more. So if someone is already poor in terms of income and then deprived in another indicator, like for example, education or health, then that person can be classified poorer. Okay, this assumption is called dimensional monotonicity. Okay. The concept of monotonicity, you have learned about it in your microeconomics. Choice or preference that are rational, they have the characteristic of monotonicity. Monotonicity means if you in terms of preference, it means that if you consume more of the goods, it means you are going to be more satisfied. With the dimensional monotonicity, if someone deprived in more than one indicator and much more than, and then there are other additional indicator that they are deprived on, then we can classify them as poorer, not just poor. So that's the characteristic of the adjusted headcount ratio. Okay. This is the MPI rankings and poverty headcounts for selected countries. Let's take a look at Indonesia is here. We can take a look at Indonesia. So this is the year of 2007. Our MPI value is 0.095 and our MPI rank is 53. And then our proportion of poor or the headcount ratio is 0.208, and then the average intensity of deprivation is 0.459, and then our proportion of poor with the 1.25 a day base. Also, this is the income poverty. Meanwhile, this is the multi-dimensional poverty. With the 1.25 a day, our proportion of poor is about 0.075, and then the rank is 31. With the $2 a day, the proportion of the poor is 0.490, and the rank is 52. Meanwhile, let's compare us with okay. Let's compare us with Thailand, for example. Oh no, let's compare us with, okay, Thailand. I think that's because Thailand is our neighbor. So this is the year of 25. The MPI is smaller than Indonesia. It means that their situation of inequality is slightly better than us. So we are more unequal compared to Thailand. Their MPI rank is higher than us right here. And the proportion of the poor, they are also smaller. And the average intensity of deprivation smaller than us, and the proportion of poor according to $1.25 a day much smaller than us. In fact, they go to the first rank here, and the $2 a day is also smaller than us. Okay, let's compare with other country who did worse than us, like India here, for example. This is 2005 data. Their MPI value is bigger than us. It means that the situation is worse in terms of inequality in India compared to us. Their MPI rank is 74. Their headcount index is 0.55. Their average intensity of deprivation is 0.53. And the proportion of the poor 0.4 here, rank 64. And the proportion of the poor with $2 index is 0.7. And the rank is 70. Okay. So Thailand is better than us, but India is worse than us in terms of inequality. In terms of MPI value here, and then multi-dimensional poverty. Okay. So multi-dimensional poverty tells us a different story than income poverty. So the results showed that knowing income poverty is not enough. So knowing income poverty is not enough. You have question? No? Okay. So knowing income poverty is not enough if our concern is with multi-dimensional poverty. So if you think merely giving money transfer to the poor will not solve the poverty problem, then you need to take a look at the multi-dimensional poverty. Okay, multi-dimensionally, Bangladesh is substantially less poor, but Pakistan is substantially poorer than would be predicted by income poverty. So according to the MPI, Bangladesh is less poor, and then Pakistan is poorer. This is based on the MPI, but based on the income poverty only, then it's the other way. So based on, let me use other color, blue. This is based on the MPI, but based on income, Bangladesh is poorer. Bangladesh is poorer. Meanwhile, based on MPI, Pakistan is poorer than Bangladesh. Okay. Ethiopia is far more multidimensionally poor, and Tanzania much less so than predicted by income poverty. So this is also the case with Ethiopia and Tanzania. And then most Latin American countries like Brazil, they rank worse on multidimensional poverty than on income poverty. So Brazil as a country, their income poverty is not as bad. But if we take a look at the multidimensional poverty, it seems like Brazil doesn't do really well. And then we also see Colombia here, but Colombia's income and MPI poverty ranks about the same. So there is also a country like Colombia who ranks, whose rank according to income and MPI poverty are about the same. Okay. Okay. And then, okay. And then we will discuss about poverty, inequality, and social welfare. What's so bad about extreme inequality? So there is a dualistic development and shifting Lorenz curve. Some styles, typologies. So let's see the traditional sector enrichment. So distribution. Let me under the modern sector. Okay, let me take a look at this. Okay, and then we have the okay. So we will have some shifting in the Lorenz curve based on the traditional sector enrichment, based on the modern sector enrichment, and then based on modern sector enlargement. So if you improve income distribution under traditional sector enrichment, what's going to happen to the Lorenz curve is it's going to shift from here to here. It will get it will result in the more equal society. Why is that? Because most of people who are in the traditional sector are people whose income are low. Okay, so most poor people, they are in the traditional sector. So if you do enrichment in the traditional sector, it will really help the poor, and it will and the Lorenz curve will shift closer to the equal line, to the equality line. So this is the equality line here. Okay, so this is what's going to happen if you improve income distribution under the traditional sector enrichment. Okay, but if you do modern sector enrichment, then the income distribution is going to be worse. Why? Because most of the people in the modern sector are rich people, right? So the inequality is going to get worse. The Lorenz curve is going to shift from here to here. They get even farther from the equality line. Okay, so this is worse. Oh, sorry, this is going to be less equal. So that's what's going to happen. If you are going to do a modern sector enlargement, so the difference between enlargement and then enrichment. So with the enrichment, you basically make the case when the resource, when the result of the economy goes to the rich people's pocket. Goes to the people who are in the modern sector's pocket, which in this case mostly rich people. But with the traditional sector enrichment, what you do here is you make sure that the result of the economy goes to the pocket of people in the traditional sector, which mostly poor people. But with the modern sector enlargement, what you do is you make sure that the expansion of the industry, for example, is going bigger. So if a country do an expansion in their industry and they open new industry location, and then it's going to have impact with the economic growth. So that's an example of modern sector enlargement. What it's going to do is it's going to cross the Lorenz curve. So the first Lorenz curve here is the L1 here. Let me this is the L1 here, and then now it will shift to the L2. This will not really this will not really change the Gini coefficient, right? Because probably the area of the half moon here, or the Lorenz curve here, is not going to change. The area is going to be the same. Remember that if I call this area A, then this is B, C, D. Remember that the Gini coefficient is Gini equals to A divided by B, C, D, right? So whether the Lorenz curve in the L1 or L2, the area of A is probably not going to change. Do you know what changed? What changed is the income distribution. So in the L1, for example, this is the poorest 20%. Their share of income used to be here. For example, the poorest 20% used to get, let's say, 15% of the total share of income. But now, because the Lorenz curve shift, now they will only get up to this point. Actually, the inequality is getting worse, right, in here, because now they only get 5%, for example. Meanwhile, in the case of richest 20%, for example, they used to get only here. Let's say this is I don't know, maybe 58%, and then now because the Lorenz curve shift, now they have even more. I don't know, maybe this is 60% in here. So they go up. Meanwhile, the poor, they go down. So this is less equal than before. So this is what's going to happen with the modern sector enlargement. Although the modern sector enlargement might have some positive impact. Like for example, if they open new industrial sector, it means that a lot of people will get hired now. If they put investment in the rural area, now people in the rural area can get a job and they can have better income. Yes, it is true, but still the income of the rich people who own the industry, for example, they are going to go even higher. So that's why the share of the rich people's income here is going to go up. Meanwhile, the poor is going to go down, even though in the number, in the nominal number, maybe they have more money than before. But relative to the rich people is going to get even higher than they already own before. Okay, so this is the crossing of Lorenz curve. Now you notice that even though Lorenz curve can shift from L1 to L2, so what's different between L1 and L2 is the slope, right? The slope of this half moon now different, but the area of the half moon doesn't change. So the Gini coefficient is still the same. Okay. Okay. And then that's for the shifting of the Lorenz curve. You have question before I go to Kuznets inverted U hypothesis? No? Okay. Okay, I will go to Kuznets inverted U hypothesis. So the Kuznets curve, we sometimes see the Kuznets in the topic of environmental economics, environmental economics, where Kuznets say that the pollution is necessary for the economic growth, and Kuznets said that at some point when an economy is growing, then the pollution is going to go high, but at some point it's going to reach their saturation point and then go down. So that's the environmental Kuznets curve. But now here we are going to discuss the Kuznets curve in the context of poverty, inequality, and social welfare. Okay, so this is the inverted U Kuznets curve. So in this case, Kuznets said that, let's take a look at the graph first. So the y-axis is the, the y-axis is the Gini coefficient and the x-axis is the gross national income per capita. So basically, the theory said that as an economic, as an economy is growing, their Gini coefficient is going to go up until at some point in the peak here. So this is the peak or the saturation point, then the Gini coefficient is going to go down. So when the gross national income per capita is growing, and so does the Gini coefficient. But at some point in the peak here, in the peak or in the saturation point, the Gini coefficient is going to go down even though the income, the gross national income per capita is still going higher. So this is what Kuznets believe. So that's why we have the inverted U Kuznets curve. Okay. Basically, this theory stated that when a country is growing, their income distribution is going to be unequal up to some point, and then they keep growing and their income inequality is going to be better. Their income distribution is going to be better. Well, does that happen in real life? It's debatable. You can argue with anything you want, but this is the theory of the inverted U Kuznets curve. Whether it happens in real life or not, let's take a look at this data. This is the income distribution estimates of some country. Wait, I don't know what is this. Oh, okay, this is the income distribution. Okay, so in, let's say, let's take a look at, do we have Indonesia here? No, we don't. Okay, then let's take a look at Bangladesh. In Bangladesh, the lowest 10% or the poorest 10%, they own about 4.3% of the total income. Meanwhile, the first quintile, 9.4%. The second quintile, 12.6%. The third quintile is 16.1%. The fourth, 21.1%. The fifth is 40.8%. If this is the poorest 10%, now take a look at the richest 10%. They own about 26.6%. Well, let's compare that to other country, United States, for example. Oops, sorry. United States, for example. Their poorest 10% only own about 1.9% of the income. Meanwhile, the richest 10% own about almost 30% of the income. So if we compare Bangladesh and the United States, we see that the US is much more unequal than Bangladesh, right? Even though US income must be much more higher than Bangladesh. So with the case of United States, can we say that the inverted U Kuznets curve actually happened? Well, probably not, because US gross national income keeps growing, right? Even until today. But as we can see, the Gini coefficient doesn't go down yet. Okay, even from a long time ago until today, the Gini coefficient doesn't really go down. So whether inverted Kuznets curve happen in the US or not, that's debatable. But it seems like it doesn't go that way. Okay, let's take a look at other example. Okay, let's take a look at, wait a minute. Let's take a look at Japan here. Japan. So the lowest 10% population in Japan owns about almost 5% of the income. Meanwhile, the richest 10% owns about 21%. It seems like the inequality problem in Japan is not worse than the US, right? Let's take a look at other country that are more equal. Oh, it seems like compared to the other country here, Japan is rather equal compared to the country here, right? Not other country who are not here, but compared to the country here, Japan is actually quite equal. Because take a look at this. The first quantile 10%, and the second 14, the third 17, the fourth 22, and then the fifth 35. The difference between each quantile is not very staggering. Like it's different from the US. Look at the US. The first quantile is only about 5%. Meanwhile, the fifth is about 45%. So the difference between quantile is quite staggering. So maybe we can kind of argue that the inverted U Kuznets might happen in Japan, but not in the US. So this inverted U Kuznets, this is case by case, right? We cannot say that it must be like this in general, no, because it is case by case. Because there is rich country, when their gross national income keeps growing, their inequality also keeps growing. And there are rich country where their gross national income keeps growing, and then Gini coefficient doesn't get worse. Okay, maybe if you take a look at Sweden, it's going to be, Sweden, maybe the case it's going to be like what Kuznets predict here. Or maybe if you take a look at Denmark, maybe it's like what Kuznets predict here. Okay, so it's case by case. This is the data of Gini coefficient and their income per capita of the low income country, of the lower middle income, upper income, and so on. Let's take a look at the low income. Let's take Ethiopia. Their Gini coefficient is about almost 0.3 or almost 30%. Meanwhile, in the upper middle income country, so this country are richer than Ethiopia. Let's take a look at South Africa, for example. Their Gini coefficient is even worse. So, like I said before, just because a country is richer, yeah, it's not necessarily that their Gini coefficient is better. And then let's take a look at Norway here. Norway is a very rich country, but their Gini coefficient is even lower than Ethiopia. Okay, so this is an example of rich country whose income distribution is quite equal. So Norway. And then you have US here, where their Gini coefficient is quite high, because even though they are rich, they have problem of income distribution. Okay. Okay. So that's the Gini coefficient. So this is the Kuznets curve with Latin American countries identified. So this is the position of Latin American country, the blue dot here. So you can identify the country are in here. Okay. 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 So this is if you want to see the income growth of Brazil, Costa Rica, Pakistan, Hong Kong, and Singapore, then you can take a look at here. Let's take a look at Brazil only, for example. Brazil only, number one. Brazil used to be here. Oh, the Gini coefficient is quite high, but then as they get richer, their Gini coefficient actually go down. But I think it's still quite high in here. Let's take a look at Singapore, for example. Singapore is number 5. So Singapore starts here. And then as they get richer, it seems like their Gini coefficient was lower. And then as they as they grow even further, their Gini coefficient is go up. So they go down here and then they go up there. That's interesting. And then we have, let's take a look at Pakistan here. It seems like Pakistan Gini coefficient is just constantly getting higher from time to time. Let's take a look at Hong Kong. Let's put blue in Hong Kong. So Hong Kong start here with the high Gini coefficient, and then as they grow, their Gini coefficient go down. Okay, so Hong Kong is a good example for the inverted U Kuznets curve. Okay, so this is the plot of inequality data from selected countries. And then from all of the data below, above, before, the first argument that I said before, that growth and inequality are trade-off. Well, after we saw the data, at some cases they are trade-off, but at some cases they might not be. I mean, they still could be trade-off, but not as bad as we expect it to be. So it's not 100% trade-off, not 100% substitute, maybe 60% substitute, but not 100% trade-off or substitute. Okay, it depends on the country and it is case by case. And then the absolute poverty, extent, and magnitude. So when we want to examine the progress on extreme poverty, it seems like if we use the measurement of $1.25 a day, there has been a clear progress. So the number of people who live under $1.25 a day now is much lower than it used to be. So there is a clear progress. Meanwhile, with the $2 per day headcount, there is less clear progress. Okay. And then incidence of extreme poverty is uneven. And then relationship between growth and poverty, association between growth and poverty reduction. So there is association between growth and poverty reduction. Like, for example, the number of poor people or the proportion of poor people in Indonesia when we were traditional, when we lean a lot on traditional sector compared to today is smaller. So the number of people has been reduced. So we can say that there is some association between growth and poverty reduction. Because when growth is inclusive, then growth can reduce poverty. What does it mean by growth being is inclusive? It means that the benefit of economic growth can be beneficial for everyone in the economy, not just the rich people, but also the poor people. And then lower extreme poverty may also lead to higher growth. So this is true. Lower extreme poverty may also lead to a higher growth. Okay. So this figure shows the long-term economic growth and income inequality. Let's take a look at this. So the y-axis here is the average annual growth in GNI per capita. Okay. So we can see that, okay, and then let's take a look at below here. Wait, what's the x-axis? Oh, the x-axis is the Gini coefficient. The x-axis here is the Gini coefficient. We can take a look at East Asia. East Asia in the 60s. their Gini coefficient was 0.39, and as East Asia grow, so it grows from here to here, right? It seems like the Gini coefficient is getting a bit worse. So from 0.39 to 0.40. Meanwhile, let's take a look at Latin America here. In the 60s, their Gini coefficient used to be 0.54, but in the 90s, as they grow, their Gini coefficient is getting smaller. So as they grow, the income has become more equal, right? From 0.55 to 0.29. Meanwhile, this is the Sub-Saharan Africa. In the 60s, their Gini coefficient is 0.51. Now, in the 90s, their Gini coefficient a little bit reduced to 0.49. And they also grow a little bit from here to here. Okay. So this is the long-term economic growth and income inequality. So in general, we can see that there is association between growth and inequality. And for growth to be able to reduce inequality, the growth must be inclusive. Okay, inclusive. When it's inclusive, it will reduce inequality. Reduce inequality. Okay. Okay. And then this is a global and regional poverty. You can see that okay, in this part is the people living under 1.25 a day in other developing countries, and here in South Asia, here in East Asia and Pacific. Meanwhile, here is in Sub-Saharan Africa. You can see the difference of poverty trends in the global region. Okay. It seems like in Sub-Saharan Africa, it's still a lot. Okay. And then the regional poverty incidence. This is the regional aggregation of $1.25 a day. In East Asia and Pacific, it's the headcount ratio is about 16%. Meanwhile, in Sub-Saharan Africa, it's about 50%, and the poverty gap in East Asia and Pacific only about 4%. Meanwhile, in Sub-Saharan Africa, it's higher. So if you square the poverty gap, it's only 1.4, it's 11. Meanwhile, if we use the $2 per day, the East Asia and Pacific, the headcount is about 38%. Poverty gap is about 13 here because 12.9. Meanwhile, in Sub-Saharan Africa, it's 72, and the poverty gap is 36. Okay. This is poverty incidence. Wait a minute. So, okay. So this is the poverty incidence in some countries. So the poverty incidence at $1.25 a day, and then poverty line at 38. We can see, let's take a look at Indonesia. We have Indonesia rural and Indonesia urban. Let's take at the rural first. So in rural Indonesia, per capita monthly income based on 2005 PPP is about $62. And then the headcount ratio in rural is about 25%. 24%. So 24% who lives in the rural area are poor, and the poverty gap is 5%. And the squared poverty gap is 1.61%, and the Gini is almost 30%. Meanwhile, in the urban area in Indonesia, the per capita monthly income is about $89, and the headcount ratio is 18%. So 18% of people who lives in the urban area are poor, and the poverty gap is 4%. The squared poverty gap is 1.29, and the Gini index is almost 40%. Oh, it seems like in the rural area, the inequality problem is worse than, in the urban area, the the income distribution is more unequal compared to the rural area. Okay, so this has shown that even in one country, the situation in the rural and the urban can be different. Okay, we can. This is, I think, the same. Oh, yeah, this is continued. Okay. Okay, then these are some characteristic of high poverty groups. They are usually rural poverty, so they are poor and they live in the rural area. And then a lot of there are so sometimes you can find that some family who are poor in the rural area, the head of the family is a woman, either because the men look for some job outside the rural area, or because the man has died, has gone, or because of something, or this woman, they have kids, but they don't have a husband, for example. So that's one of the characteristic in the high poverty groups. And then you can also find that sometimes they are part of the ethnic minorities, or sometimes they are indigenous populations, and then they live in the poverty. Okay. Now this is data of poverty in the rural versus in the urban. Let's take a look at Indonesia. The rural population, so percentage below national poverty line in the rural area is about 20%, in the urban is about 12%. Meanwhile, nationally, the poor population is about 16%. So poor people, the proportion of poor people in the rural area is higher than the average national. I think it's similar to other country as well. Like, let's take a look at Guatemala here. The poor people in the rural area is 72%. Meanwhile, in the urban, it's about 28%. The average national is 51%. Okay. So this is the indigenous poverty in Latin America. In Mexico, in Mexico, the indigenous population is about 80%. Oh, sorry. The people who live below poverty line, who are indigenous, is about 80%. Meanwhile, non-indigenous, those who live in the poverty line, only 17.9%. Okay. So these are the policy options on income inequality and poverty. Some basic consideration. So the policy to overcome the inequality problem should consider some of these consideration. So the in terms of areas of intervention, some of the options could be altering the functional distribution, or mitigating the size distribution, or moderating the size distribution at upper level, and moderating or increasing the size distribution at lower level. You still remember what size distribution, right? This is where we break down the population in terms of quantiles or deciles. So we can moderate or reducing the size distribution at top level. It means that we have to kind of not prevent, but moderating, so that the rich people at the top, they do not staggeringly getting richer. So we want more equal income distribution, right? So we have to moderate that, and then in the lower level, we have to moderate or increase the size of income distribution to the lower level. So this can be the option of the area intervention. And then some of the policy option, we can change relative factor price. Relative factor price, for example, like wage. So if the government they set wage at some cut-off point, then they can help, for example, well, theoretically, they expect to help some people who have low wage before to get a higher wage. But can that actually apply in real life? Well, it's complicated, because the truth is, if the wage rate is too high, the firms or the industry might not want to hire more people. But theoretically, that's what they expect to do. And then progressive redistribution of asset ownership. So the government can try to have more equal asset ownership. So not just some group of rich people who own assets. Well, the government can try that by, for example, setting that one person cannot own more than 2 firms or anything, or yeah, things like that. So the asset ownership can be redistributed, and then progressive taxation. This also apply in Indonesia because our tax is progressive, and then transfer payment and public provision of goods and services. So an example of this is when the government they have BLT, and then they build school, and then they build railroads, and other public goods. Okay, so this is the summary of today's chapter. The need for a package of policy. So we need policy to correct factor price distortion, and then we need policies to change the distribution of asset, power, and access to education and associated employment opportunities, and then policies of progressive taxation, and then direct transfer payment, and then policies designed to build capabilities and human social capital of the poor. Okay. So I think that's all of the material for today. These are some concepts that you can review yourself. Okay. Any one of you have any question regarding the material? Regarding the midterm exam, don't worry, because I will give you the whole information by email. So you can access the information about, I don't know, maybe 1 week before the exam takes place. So don't worry about it. Like I said before, the exam is going to be multiple choice. It's going to be 2 hours long. It's going to be open book, and it's going to be on Google Form. And the Google Form will only be up during the duration of the exam. Okay, so 9:40 to 11:40 at April 7, 2021. Okay, open book, but cheating is prohibited. So if I can prove that you cheat, I will not grade your exam. Okay. Okay. Chapter 6 will be up in the form of a YouTube video, and the material for the exam is going to be chapter 1 to chapter 6. Okay. Okay. If you don't have any question, I will end today's session. Thank you for coming. Have a good night. Have a good rest of the day. And then good luck for the exam. I hope you can ace all of your midterm exam. Okay. Bye-bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Ma'am.
Không ngừng.